All good things must come to an end. Thus, working with square roots. The next video we will look at we will be being introduced to Pythagorean theorem. But anyway, now think ahead. Sometimes when we are simplifying square roots, we can also add and subtract these radical expressions. But what we have to do is simplify a term first and then combine any like terms, especially when they are non-perfect. This is what we're still dealing with. So let's take a look at two examples, and then this will conclude our series. So here we have 3 square root of 2 minus square root of 8. So when we take this into consideration, what can we do? If you look at the square root of 8, inside of this radican we have a perfect square, which is 4 times the square root of 2. So let's just go ahead and rewrite it. 3 square root of 2 minus square root of 8 is equal to 3 square root of 2, and that's going to be minus, and inside of here let's go ahead and put 4 times 2, because these two factors still give us that radicand of 8. Now where we going from here is we will take 3 square root of 2 minus, but now we can take the square root of 4 and give 2 times the square root of 2. This make this real easy now for us to add, because going back to adding or subtracting, remember what we're going to do is we're going to take our leading numbers that's not inside of the radical, and that'll give us 3 minus 2 square root of 2, and then of course 3 minus 2 is 1, so that will just give us square root of 2, because we know that 1 exists. I'll go ahead and put it here just in case you have forgotten that it does exist, which is still simplified to square root of 2. Okay, combining it's just simply once you get these expressions or these radicands simplified, then you're really in good shape. Let's take a look at one that's a little bit complicated, but it's still just as good, just as easy. And I'm going to change my colors here because I know I'm going to look at something closer. So here I have the square root of 12 plus the square root of 75. Now as I look at that, I look at my 12, and inside I see factors of 4 times 3. So I can say the square root of 4 times 3, and here I know 4 is a perfect square. That's what I'm looking for. Plus, now, what are factors of 75 that we can get a perfect square? 25 and 3. So here we're looking at plus the square root of 25 times 3. Okay, as we go on, now that we've found 2 perfect squares on the inside, let's simplify them. And we see the square root of 4 is 2, then we have times the square root of 3, plus, and the square root of 25 is 5 times the square root of 3. And again, we have like terms because radicands 3 and 3 are like terms, so we can simply just go and say now 2 plus 5 square root of 3, that will give us 7 square root of 3. And again, we're just in the simplification mode. We're not trying to evaluate the square root of 3 or approximate the square root of 3 and come up with an answer. But anyway, it's really straightforward. I hope you have fun with it. You know, if you have your book at home and you went through these and you want to work some problems from your textbook and bring them in and let me look at them, and of course, you know, there's always a reward for doing great. Thank you, and I'll see you soon.